Hello all and welcome to the algebra video for solving equations with variables on both sides. So equations with variables on both sides. Before this, definitely you should know how to solve one and two step equations, which is something I've talked about in previous videos. Also, knowing how to solve multi-step equations. Okay, so what we actually, if you follow these in succession, what we just did. Okay, so the steps to solve an equation with with variables on both sides is almost exactly the same as the steps to solve a multi-step equation. Okay, first one is distribute. Okay, so if we have the distributive property we need to do, just like last time, it's going to be if necessary. As you'll see on a lot of these first examples that we're going to do, a lot of them you don't have to distribute because it's just not necessary. Same thing can be said for combining like terms, which is the next step. So after we distribute, we combine like terms. I'm going to add a little caveat in here. Combine like terms on each side. Okay, and then once again, this is if necessary. Because once again, on some of these examples, you'll see it's not necessary that we combine like terms on each side because there's no like terms on just on one side. Okay, so what changes and what's different from solving any old multi-step equation to solving with an equation with variables on both sides is this third step. Okay, and that's step 3, move variables to one side, and I put here usually to the left. Okay, now when I work every one of these examples, it's my personal preference that I like to move the variables to the left-hand side, so that way it is in the same form of all the other equations that we've solved up to this point. Okay, and then the last step, once we do that, and once again, if you're a little confused about what I mean by that, we're going to look at some examples here in just a few, in just a second. But that's the big step that's different than any of the other types of equations we've done so far. Okay. But then we have the fourth step here is solve. So much like the last step in solving multi-step equations, we're going to have a two-step equation when we get to the end here, at least a two-step equation. Might also even have a one-step equation. So just solve the resulting equation, and it works just like solving any one or two-step equation. Okay. But let's go ahead and jump into some examples, okay, because that's all that's really left to do. Just look at some examples here. So the way we do these examples are the exact same way the homework's going to work, okay? So definitely pay attention, definitely follow along, and then you'll see what solving equations with variables on both sides is all about. Okay, so we start off with number 1. We have 5y minus 8 here on the left, and we're told that that equals 3y plus 12. Okay, now this next step that I do isn't 100% necessary. It's one that I just like to do because I like seeing my terms, seeing what's positive, what's negative, and I like having addition everywhere. So that way, in case if I need to flip terms around or do anything like that. So I'm going to rewrite this expression or rewrite this equation using sums. Okay, so right here, all I did was write it as a sum. So now we see, okay, well, we've got a variable term on the left-hand side, 5y, and we have a variable term on the right-hand side, 3y. You do have the option here. You can actually subtract 5y from this side and also this side, but that's going to end up moving the variable exclusively over here to the right. So what I'm going to suggest doing, and this is just, like I said, the way that I like to do things in terms of how I like to solve equations, is I'm going to move my variable from this side to the left-hand side. And how we do that is if we have a positive 3y over here, we're going to subtract a 3y. Okay? So the point here is those 3y's are going to go away, and we're going to be left with 12. Okay? But this is an equation, and you can't forget, if you do something to one side of an equation, you got to do it to the other. So in this case, if we subtract 3y, we got to subtract 3y on this side of the equation too. Once again, I'm talking about the sides split by the equal sign here. And then, so we got to look, and this kind of, you got to have an idea about like terms here, because if we look, we're going to be subtracting a 3y. Well, which term can we subtract 3y from over here? Well, it's not going to be the -8. It's going to be the 5y. So I'm going to subtract it from the like term. So what happens here is we have 5y minus 3y gives us 2y. This plus -8 just drops straight down. And now we've got basically a two-step equation that you can solve from here. But I am going to take it one extra step, because since we have plus a -8 here, I'm going to write it back in the way that it was at the start and write it back as a -8. But then, once again, two-step equation. I shouldn't have to go through too many steps here. We're just going to add 8 to both sides. 2y is equal to 20. So we divide by 2. Y is equal to 10. And that is the first example of an equation with variables on both sides. So notice, after we got rid of the variable on the one side, it works just like any other two-step equation, okay? But notice there weren't any parentheses, okay? So there wasn't any distributive property that we had to do. And once again, there's no like terms here that we can combine on either side. So we jump straight to step number 3, which was subtract or move the variables from one side, okay? So once again, I chose to get rid of the 3y here. So if I do that, I got to subtract 3y over here, and then we get a two-step equation, okay? Same thing's going to happen with number 2, except once again, I have -6x plus 14 is equal to 12 minus 8x. Well, once again, my first step, and like I said, this isn't 100% necessary, but if it helps you see what's going on, I'm going to write it as a sum, so that way I can see, well, what do I actually have here? Okay, my terms, I have a -6x on the left-hand side. I have a -8x on the right. I have a 14 on the left, a 12 on the right. So now I'm going to do one more rewrite just so I can put it in the same form as what I did on the last one. I like having my variable term first, then my constant term. So now it looks exactly almost what we had over here. The only difference is, once again, we have negatives here, so -6x, -8x. So to get rid of a negative, so in this case I'm going to get rid of the -8x, because once again I want to move my variable over here to the left, is you have to add 8x, okay? So how do you get rid of a negative by adding? Well, you add whatever it is. So -8x, we're going to add +8x, okay? The whole point here is we want those to go away, and then we can see we're just left with 12 on this side. But just like this other example over here, if we add 8x to this side, we got to add 8x over here. But then once again, our like terms idea has to come into play in terms of, well, which am I going to be able to add 8x to? The -6x or the 14? Well, it's going to be the -6x. So -6x plus 8x will give us 2x. We still have the plus 14. It just dropped straight down. We didn't do anything with that just yet. And once again, we just have a two-step equation where we subtract 14. 2x is equal to -2. And then we just divide by 2. So we get x is equal to, once again, those go away, -2 over +2, it's a -1. Okay, so once again, the hard part is at the beginning where you have to realize, oh, I have variables on both sides. How do I get rid of the variable on one of the sides? And if if you feel like it, you can actually have added 6x to both sides if you wanted to. So you would have gotten 14 is equal to -2x plus 12. And then you would have had a two-step equation that way. But once again, I like having my variables over here on the left. So I always take the variable that's over on this side, the variable term on the right-hand side, and either add or subtract it over. So that way it gets rid of it and we only have a variable on the left. Number 3, special little example here, because if you notice, we have 7k, and that's it on the left-hand side. So we have 7 times k is equal to 3k minus 36. Well, same kind of thing there. Once again, this isn't necessary, but I just like having everything be addition, so that way I can move terms around if I need to. But then I can clearly see, well, what do I have on the left versus what do I have on the right? My term on the left is 7k. My terms on the right are 3k and negative 36. So just like what I did before in the other examples, I'm going to get rid of this 3k. I want to move it over here. So if I do that, I have to subtract 3k. But if I do it to this side, I've got to do it to the right hand or the left hand side. So 7k minus 3k, that gives us 4k is equal to, then once again, there's no constant term over here, so it's just 4k is equal to, well, the whole point is we want those 3k's to go away, and now we just have negative 36 left over. Okay, it just comes straight down. And actually, in this case, we just have a one-step equation where the only step we have to do now is divide by 4. So we get k is equal to negative 36 over positive 4 is a negative 9. Okay, so you can see how all these pretty much work the same. And if you struggle with this and you follow along, if you do it the same way I do it, like I said, I just get in the habit. I'm always move my variable on the right-hand side to the left. Now, that's not to say you could have subtracted 7k from both sides here. In that case, you would have had 0 is equal to negative 4k plus 36, or plus negative 36. And then, once again, I probably wouldn't have done it that way because I don't like having 0 on one side of my equation. But once again, it would still work out. Any way you did it, you should still get the same answer as k is equal to negative 9. Number 4, very similar. Okay. Once again, I'm going to rewrite it as a sum so I can move my terms around if I need to. And I'm actually going to want to this time because when you're starting off, you have 12 minus 2u. Well, some of you have gotten good enough to where you could just see, well, if I want to flip that around, it's going to be negative 2u plus 12. Well, how we can clearly see that is write it as a sum, and then I'm going to change these two around. So I can write this as negative 2u plus 12 is equal to 9u plus 45. Okay? And once again, I know I sound like a broken record, but it's exactly the same as the previous 3 examples that we did. Once again, you could technically add 2u to both sides, but I'm going to subtract 9u from both sides. And once again, you got to subtract the term from the like term over here, so you got to subtract the u term from the u term. Okay, once again, those go away, leaving us 45 over here. Negative 2u minus 9u, that's going to give me negative 11u. And this plus 12 is still just hanging out there, so we just drop it down. And then once again, two-step equation where we subtract 12. Negative 11u is equal to 45 minus 12. It's actually 33. And then we divide by negative 11, divide by negative 11. So those go away, giving us u is equal to positive over a negative is a negative. 33 divided by 11 is 3. So u is equal to negative 3. All right, so, and I'm just going to keep going on here because, once again, numbers 5 and 6, very, very similar to all the examples we just did, except for number 5. We do have this little issue where we have subtraction on both sides, and then the terms are kind of a little bit weird here. So, once again, my suggestion to you, if you struggle with subtraction and everything, let's write it as a sum. Another thing that you just saw me do right there is I put a 1 in front of the m, just so I can clearly know that the number in front of this m is negative 1. But now I'm going to flip things around. So this is actually going to be negative 1m plus 11 is equal to negative 6m plus 51. And like I said, you have an option here. You can either add 1m to both sides, or you can add 6m to both sides, which is what I'm going to do. Once again, I want to add because since this is a negative 6m, In order to get rid of it, a negative plus a positive 6m goes away, gives me 0. So then we're left with 51. Negative 1m plus 6m, that's 5m plus 11. And that's equal to 51. And then once again, bada bing, bada boom, we have a two-step equation where everybody should probably be able to do these in your sleep by now. So 51 minus 11 is 40. The 11s go away, so divide by 5. Divide by 5. M is equal to 8. Okay. Once again, this step up here where I write it as a sum, write each side as a sum, that's not 100% necessary. You could have seen up here where I'm subtracting 6m, so I need to add 6m. Same idea here, okay? Same thing on this side. But it's a little harder to see here because if you added 6m here, it's like, what am I adding the 6m to? So I do strongly suggest, if you do have trouble seeing, okay, what am I even adding here? What are my coefficients? What are my constant terms? Once again, if you just write it like I've done here, if you write it as a sum, as I'm going to do in number 6 here, and I'm going to do it with every one of them, it's clear to see what I've got on each side, what my terms are, what I need to add, what I need to subtract. Okay, I'm going to do the same thing here with number 6. So we have 10k plus 1, or negative 10k plus 1 is equal to 40 minus 7k. Well, once again, if it's not very clear, we can flip that around if we wanted to. It's going to be negative 7k plus 40. But to clearly see that, write it as a sum. So write that subtraction as addition. And now we can flip the term around. Negative 7k plus 40. And now, once again, we're in the same spot that we were in example 5, example 4, example 3, example 2, and example 1, where we have a variable term plus a constant is equal to a variable term plus a constant. So I'm going to add 7k to both sides this time. Once again, I'm going to add 7k since this is a negative 7k because we want those to go away. So we have 40 on the right. Negative 10k plus 7k, that's negative 3k. Plus 1 is still hanging out here. So two-step equation time again. Negative 3k is equal to 39. Divide by negative 3. Divide by negative 3. So we get k is equal to negative 13. Okay. Notice I am just glossing over the two-step equation stuff there. So if you do need practice with that, or you do need more in-depth talking about, me talking more in-depth about two-step equations, go back and look at the 1 and 2 step equations video, okay? Because I do go over it there. So what we're concerned about right here is what we do up here that gets us to a place where we just have a 1 or 2 step equation to solve, okay? Now, starting with number 7, this is our first example where we actually come across having to use the distributive property, okay? So the dead giveaway of the distributive property here are the parentheses. So we have 3 and then in parentheses times 6p minus 1, and then that's equal to 11p minus 45. So first thing I'm going to do is I am going to distribute this 3. So 3 times 6 gives me the 18p. Minus 3 times 1 is 3. And then everything else stays the same. So there's step 1, distribute. We still have no step 2, so there's nothing I can combine over here. There's nothing I can combine over here, so we just go straight to step 3. But before we do that, I am going to do my tried and true method here of writing this as a sum so I can clearly see what's going on here. So I have an 18p on this side, 11p on this side. Technically, I could subtract 18p from both sides because I could get rid of that and then have negative 3 over here. And then over here would be negative 7p plus negative 45. Once again, that seems a little tricky there. But I'm just going to keep doing the same thing I've been doing. I want to get rid of the 11p on this side. That means I have to get rid of 11p on this side too. So those go away. So we have what's left is negative 45 on the right. 18p minus 11p, that gives me 7p. We still have the plus negative 3 there. And technically from here, you probably be able to solve that equation, but I am going to take it one extra step here. Since I have plus a negative, I'm just going to rewrite that as 7p minus 3. So that means, that shows me I need to add 3 to both sides. 7p is equal to negative 42. Divide by 7, divide by 7. P is equal to negative 6. Make sure to cross those out there so that way we can see what's going on. So negative 45 plus 3, negative 42, negative over a positive is a negative. 42 divided by 7 is 6. Okay. Number 8, very similar, except for now we've got distribution on both sides, and you'll actually see we're going to have to combine some like terms. If you see this plus 4 over here, okay, that's actually indicating to us we're going to have to combine some like terms. But first things first, let's distribute. So 2 times 4w is 8w minus 2 times 1 is 2. So that's pretty easy right there in terms of the left-hand side. Right-hand side, a little harder because we have this negative here, but negative 10 times w is negative 10w. And I'm going to take a little shortcut here, okay? So try to follow along with me. I've got a negative 10 that I'm going to distribute. Well, I have minus 3 in here. Well, we know 10 times 3 is 30. But since this is a negative out here, it's going to change this minus to a plus. So this is going to be plus 30. And once again, that's because I'm distributing a negative. The negative is going to make whatever this sign is opposite. So if we wrote it out as a sum, it would be w plus negative 3. Well, negative 10 times negative 3 is a positive 30. And then we can't forget the plus 4 on the outside here. But we're still not done with the setup because now we got to do step 2. We did the distributing. But now on the right-hand side, we actually have 2 like terms we can combine here. The 30 and the 4. So if we do that, we have plus 30 plus 4. That's going to be a plus 34. And now, just like all the examples beforehand, we're at a spot where we can solve this. But once again, not to confuse anybody, I'm going to write this as a sum just so I can see what's going to be left over, all this kind of stuff, so I can see, okay, what am I adding together here? So I'm going to add 10w to both sides. And once again, you could subtract negative, or you could subtract 8w from both sides if you wanted to. But like I said, I like to get rid of this term over here, so it's negative 10w plus 10w. Those go away. So that's we're left with 34. 8w plus 10w is 18w plus negative 2. And like I said, some of you from here could solve it, but I'm going to do just one extra step in writing this out a little bit nicer to get rid of this negative 2. So instead of plus negative 2, it'll be minus 2. And then same steps as always. Add 2, 36, divide by 18, divide by 18, boom, w is equal to 2. Okay, so w is equal to 2. Once again, once we get to this part, it's the same every single time, 2-step equation. Okay, same steps, just the numbers change. Okay, and notice how I write this out every time. Every question ends up being almost the same question. It's just sometimes we have different numbers. Sometimes we have negatives here. So we have to add a 10 instead of subtract a 10w. Okay. So just really pay attention to your negatives, especially when you're distributing. Okay. That's the tricky part on this one. Like I said, if you don't see what I did right here, okay, negative 10, and then you have minus 3, that's going to change it to a plus 30. 10 times 3 is 30. Negative, negative, positive. Okay. Going on here, so just 4 more examples. And that's pretty much it. That's how these work, okay? Now, they are going to get a little bit tougher as you go along on the homework and with the examples as you see here, because there's a lot of distributing, combining like terms that you might have to do. But it's no different after you distribute to any multi-step equation. It's just there's just the added thing where, in this case, I already see I'm going to subtract 7m from both sides. But first things first, let's distribute, since we see the distribution we need to do here. So 9 times n is 9m, minus 9 times 3 is 27. Okay, so 9m minus 27. We still have plus 3m, and that's still equal to 7m plus 43. But just like in the question before, except for it's on the left-hand side this time, we can combine the 9m and 3m, but where I have this subtraction, just to make it very clear what I can add and together and what I can't, I'm going to write it as a sum. Now, what can I combine on this left-hand side? Well, I can combine the 9m and the 3m, so that's going to give me 12m. And once again, we're at a spot where we can go on to step 3. So we combine the like terms. I'm going to subtract 7m, subtract 7m. 12m minus 7m gives me 5m. That's still plus negative 27 is equal to, the whole point here is we want those to go away, and we're left with 43. Okay, now before we get to solving the equation, I am going to do the extra step of simplifying that a little bit so we get rid of that negative. So plus negative 27, same thing as minus 27, which you see we had up here. So some of you are probably like, well, that's kind of a waste because we just wrote it as a sum just to turn it back. Well, once again, I like to see, what are my terms? 9m, negative 27, 3m. What of those can I combine together? Well, the 3m and the 9m. Okay, so now when we come back, we're going to have to add 27. So we get 5m is equal to 43 plus 27. It's bigger numbers here, but you can see if we add the 7 to the 43, that'll give us 50 plus 20. This is actually going to be 70. Then we divide by 5. So we get m is equal to 70 divided by 5. That's not one that's on your times tables, but it should be easy enough here. 70 divided by 5 is 14, especially if you have a calculator. So m is equal to 14. Number 10, this is the trickiest one so far because you see we got a bunch of negatives and minuses going around here. So in this case, you got to see, well, what am I going to distribute? Well, a lot of people would say, well, I'm just going to distribute the 7 because that's the number that's in front of the parentheses. But you have to pay attention to also what is in front of that number. Over here, we distributed a positive 9 because there was nothing in front of the 9. That means it's positive. Over here, though, there's something in front of the 7. What is that? Well, it's a minus sign. So that actually tells us we're going to distribute negative 7. So just like always, I'm going to go ahead and rewrite this as a sum. Even this side over here, because we have subtraction on the right-hand side too. Now I can see, well, what am I going to do? I'm going to distribute negative 7. So I'm going to have negative 16 plus negative 7 times 2 is negative 14a plus negative 7 times 3 is negative 21. And then over on this side, I'm going to go ahead and flip it around. We have negative 2a plus 23. Okay. But then we run into the same thing. We have only one variable term here, so that's going to be negative 14a. And what are we going to add to it? Well, once again, if we write this as a sum, what are we combining? We're combining negative 16 and negative 21, which gives us negative 37. Okay. And then, just like before, we still have everything on the right-hand side. The only thing I did over here was I wrote it as a sum, and then I flipped it around, so that way I could have my variable term first. And now we're at a spot where it works exactly the same. So I'm gonna add 2a to this side, add 2a to this side, those go away. I'm left with 23. Negative 14a plus 2a is negative 12a. We still have the plus negative 37. So we're dealing with some bigger numbers here, okay? But same kind of thing. I'm going to rewrite this. Let me do it like this. There we go. I'm going to rewrite it one more time. Instead of plus negative 37, it's going to be minus positive 37. So now I can clearly see I need to add 37 to both sides. Those go away, so I'm left with negative 12a is equal to 23 plus 37 is actually 60. Okay. And then the last step is let's divide by negative 12. So those go away, so we get a is equal to positive over a negative is a negative. 60 divided by 12, that one is on your times tables if you remember from 3rd or 4th grade. 60 divided by 12, that is 5. So the answer here is negative 5. And we're in the home stretch here, so just 2 more examples. And these are doozies here, okay? Especially number 11, because we have distributive property on both sides. You see some subtraction here, okay? And there's going to be a lot of combining like terms, well, at least on the left-hand side. So we look at this. We see 2 sets of parentheses. That means we're going to have to do distributive property twice. But on this side, we do have to pay attention. It's just minus what's in parentheses here. Well, just like any variable, if you needed to, if there's nothing in front of a set of parentheses, technically you can add the number 1 there, okay? So what that means for us is when we write this as a sum, it shows us what we're going to actually be distributing here on the first side or on the left side is a negative 1. Okay. And then on this side, the same kind of thing, except for it's going to be a negative 2. All right, so step by step here, we're not doing anything with the 5x yet, so let's just leave it there. Plus negative 1 times x is negative 1x. Plus negative 1 times negative 18 is a positive 18. Then we have 6 plus negative 2x plus negative 30. We actually have combining like terms on both sides here. On the left-hand side, we can combine the 5x and the negative 1x to give us 4x, and then we still have the plus 18. On this side, there's only one variable term, so that's negative 2x. But what are we going to add to it? Well, in this case, we've got 6 plus negative 30, which is negative 24. Now, once again, if you do have problems adding and subtracting and dealing with negative numbers like this, definitely use your calculator to double check it. So if you do 6 plus negative 30, negative 24. And then once again, we're in a spot where it works just like every other question. Negative 2x here. So I'm going to add 2x. Add 2x. So 4x plus 2x is 6x plus 18 is equal to, those go away, and we're left with negative 24. We subtract 18, 6x is equal to negative 24 minus 18, okay? Once again, be careful with your negatives, but that's going to give us negative 42. And the last step here, divide by 6, x in this case is equal to negative over positive negative. 42 divided by 6, 7. So negative 7. And then the last one here, okay? This one, similar to number 11, except for the distributive property has to happen all on the left-hand side. So we have 2 distributive properties on the left-hand side. But once again, the first one's pretty clear. We're going to distribute an 8, okay? So that part's pretty clear. But what's unclear is what do we distribute here? And once again, a lot of people would say, well, we're just going to distribute the 2. So we would have minus 2y minus 2, okay? But that's not technically correct. And we can see that if we write it as a sum because we would have, so let me finish it out on this side. we would have negative 2 here that we're distributing. So 8 distributed would give us 8y plus 8 times 4 is 32, plus negative 2 times y is negative 2y, plus negative 2 times negative 1 is a positive 2, and that's all equal to, and the only thing I'm going to do on this side is, once again, I wrote it as a sum, so now I can flip it around, 3y plus 70, or negative 3y plus 70. So on the right or the left-hand side, we got a lot we can do over here, so we can combine 8y and negative 2y to give us 6y, plus 32 and 2 is 34. And once again, we're not doing anything to the right-hand side this time. But now we see we got a negative 3y, so let's add 3y. Add 3y to this side, so that gives us 9y plus 34 is equal to, well, those go away, so we're just left with a positive 70. Then we subtract 34. Those go away, so we have 9y is equal to, once again, bigger numbers here, okay? So definitely, if you need to, double check yourself on a calculator. But 70 minus 34 is actually 36. Then we divide by 9. Y in this case is going to be positive over positive, a positive 4. Okay? So once again, that's all this section is about. So the thing here is just make sure you follow the steps in terms of if there is distributive property, you need to do that first. So first distribute, then combine like terms, and then solve it just like any other two-step equation. Well, combine like terms, then move one of the sides over, okay, variables from one side to the other, okay. Once again, just by habit, I like taking what's over here. So if I have a negative 2x, add 2x, negative 3y, add 3y, 7m, subtract 7m, okay. So I like to take my variable from the right-hand side and move it to the left, okay. But once you do that, like I said, it works just like a two-step equation, which everybody at this point should be able to do in your sleep, okay? If there are any questions, please don't hesitate to ask, but definitely go through and practice this. And then make sure when you're doing your homework, just like any equation, you can actually go back and check. Now, it makes it a little harder here, okay, because you got a lot of stuff going on up here, but take this 4 and plug it back in. 4 plus 4 is 8, times 8 is 64, so that part's 64. 4 minus 1 is 3, times 2, that's 6. So 64 minus 6, okay, well, that would be 58. Well, what are we going to get on this side? 70 minus 3 times 4, well, 70 minus 12, that's 58. So 58 is equal to 58. That means 4 is the answer. So once again, just like any equation, you can check your work by just plugging in the number that you get back into the original and making sure both sides are equal, okay? But other than that, like I said, if you do have any questions, please let me know. And thank you for watching.